Yo, what's up everyone? Welcome to States of Matter Part 4. Today we're going to be talking about diffusion and effusion. This is going to be the last part of our that we talk about gases. Okay, so let's start with diffusion. You're probably used to diffusion. Diffusion is what happens when you have some sort of gas particles separated by a divider from the rest of the container. So what happens is that when you get rid of the divider, the gas particles are going to move to fill up the volume of the container evenly. So it goes from being kind of contained to the left-hand side to being spread around the entire container. And that's diffusion. Effusion works a little differently. Effusion is what happens when you have gas particles on one side of a container and you have a divider, but this time the divider has a little gap in it. And what's going to happen is that the gas particles starts to move to the other side, and eventually it gets to a point where you kind of have an even distribution all throughout your entire container. So diffusion and effusion is happening all the time. It's like if you have like an air freshener or whatever, they start from one side of the room, but eventually the gas particles are going to move to fill up the entire room kind of evenly. So let's talk about Graham's law of diffusion. Although this is Graham's law of diffusion, it also kind of works for effusion. And it tells us that the rate of diffusion of one gas over the rate of diffusion of the other gas is equal to the square root of the temperature of the first gas times the molar mass of the second gas over the temperature of the second gas over the molar mass of the first gas. And to see how this works, let's do a problem. So a gas diffuses 1/3 as fast as oxygen at 100 degrees Celsius. This gas could be... Alright, so let's start with what we know. We know that R1, let's set R1 equal to the oxygen, and it's going to be at a temperature of 373 degrees Kelvin. This is because we have 100 degrees Celsius, and so you just add 273 to that to get Kelvin. And we know that the molar mass is going to be 32 grams. R2 is going to be our mystery gas, so let's just name it X. We know that the temperature is going to be the same as the oxygen, so it's going to be 373 Kelvin. But we don't know the molar mass because, again, we don't know what the gas itself is. Okay, now we also know one more thing. We know that R1 over R2 is going to equal 3. We know this because the mystery gas is going to diffuse 1/3 as fast as oxygen. So if we say that the rate at which the second gas diffuses is 1, the rate at which oxygen diffuses would be 3. So R1 over R2 is going to be equal to 3. Using this, we have all the information that we need to solve the problem. We know that the first temperature, so this is temperature 1, molar mass 1, temperature 2, molar mass 2. We know that temperature 1, 373 Kelvin, times the second molar mass, we don't know what that is, over the second temperature, so 373 Kelvin, times the first molar mass, so 32 grams. We know all of this is going to equal 3, and that's because we found that out here. So the temperatures cancel out, and what you're left with is the fact that the square root of M2 over 32 grams is equal to 3. You can square both sides, so that gets rid of the square root, and you're left with this. So M2 is going to equal 288 grams. This means that the molar mass of our mystery gas is going to be 288 grams. And given our answer choices, there's only one gas that could be this gas, and it's going to be C5F12, which has a molar mass of 288 grams. I hope this was helpful. I hope you were able to learn something, and if you have a question, feel free to leave a comment, and I hope to see you later. Thank you.